Hi, good afternoon. I am grateful to have a presentation to you part of the Manufacturing Technology Conference. My name is Firat Buyukcivelek. I have been a design engineer for the last 16 years, working now as mechanical architect at ASML NXT wafer stage, and also DfMA competence lead and lecturer at Microcentrum. Today, I would like to talk to you about design for manufacturability and assembly, very briefly, and the importance of supplier design team communication. I would like to base my story on ASML core values, which are care, collaboration, and challenge. By care, we simply mean respect and trust to each other. By collaboration, we mean working together as one big team to deliver the best. By challenge, what we mean is pushing the boundaries and not accepting any excuses nor barriers to reach higher limits. As you see, this is an NXE machine, and one EUV system contains 100,000 parts, 3,000 cables, 40,000 bolts, and around 2 kilometers of hosing. An EUV system weighs approximately 180,000 kilograms. So this is a really quite complex product, and we cannot do it ourselves. We need the suppliers, the design teams working on that together over many years. The term manufacturing could be used for monopart production, traditional and non-traditional methods. In Latin, it means made by hand. What about design for manufacturability and design for assembly? Making parts that are easy to manufacture, easy to assemble simply. When design teams start the design, we take several design fundamentals into account. These 6 fundamentals are performance, manufacturability, reliability, cost of goods, test coverage, and serviceability. Today, we would like to focus on manufacturability. The most critical one might be the functionality, as it puts you in the market in the game. Reliability is essential to keep you in the market, whereas manufacturability determines the profit. For today, manufacturability also strictly determines the availability. The list could be expanded further, of course. For instance, you could add safety. When we talk about PGP, V-model explains it very well. Regarding manufacturability, where do we need to take this into account? Traditionally, designers work on the design and then they throw their TPDs over the wall to the manufacturing departments or suppliers. However, is this the way forward, or should we change it? As the name implies, DfMA is there to consider manufacturability and assembly during the design phase. We would not like to throw the designs and let suppliers suffer, but instead we would like to follow the principles, the design rules, lessons learned. Actually, we still want to focus on the right side, but mostly for securing the capabilities and lessons learned for future designs. Let's go over the core values one by one and start with collaboration. I strongly believe every designer should visit the suppliers regularly. Here I would like to mention 2 success stories. One about manufacturability and another one about the measurements strategy. The cooling blocks you see here were being manufactured traditionally by milling and then laser welding. As some of you may heard already, at ASML we ramped up our production from around 200 NXT systems per year to gradually to 400 and 600. And time frame to achieve this is only 2 or 3 years. What will be the outcome of such dramatic demand change? Like ASML, several suppliers face difficulties. Not only logistics, but also technical difficulties. Manpower, available machines, planning, you name it. Part of the project, together with the supplier, within only 3 months, the design team and supplier, based on the original design, were able to translate the production from traditional method to non-traditional additive manufacturing. An amazing success rewarded by Excellence Award. More than 1,000 sets were produced, over 1.5 million euros saving. The second success story is about this yellow plate. This yellow plate has tens of interfaces. to several other parts. There are more than 100 holes, well in operations with tight requirements. The part has been in serious production, however, with the ramp up, plus some raw material issues, there were dramatic deviations, to be honest, more than 200 in just 6 months. How would you attack such an impact? Again, with a successful collaboration between the design team and supplier, 2 workshops at the supplier were organized. There, we reviewed the manufacturing process in detail, the requirements, capabilities, and measurement strategy. 2 important findings. Part was not measured on a clamped state, whereas most of the requirements were clamped state. Secondly, for measurements, all holes were measured in total 820 plus measurements, with a measurement time of more than 3 hours. Based on SPC and manufacturing steps, we were able to reduce the measurements down to 230 without any sacrifice on quality. If your holes are milled in one step, if you are sure your milling program is verified, then why do you want to measure all hole sizes, for instance? Measuring the first, middle, and the last will be more than enough. At the end, the desired move rate of 5 is met, around 40,000 euro per year cost of goods improvements achieved, huge DN reduction, and also the supplier is not required to invest on a CMM machine, which costs around 250,000 euro at the end. The second pillar, the second core value, is the challenge. Regarding the previous cases, the success come up with the challenge in each other. Suppliers to challenge the design teams about requirements, and we challenge back with processes, and again, of course, with our requirements. A missed opportunity, for instance, was to consider these manufacturing techniques early in design. So proactive communication about the requirements, materials, or processes as early as possible would be a great moment to challenge each other. For instance, for casting, for additive manufacturing, these decisions, when made early in PGP, would optimize the design per requirements and processes. For instance, the 3D printing of the cooling blocks might enable much better optimized inner geometry for cooling purposes. We as design engineers need to understand how our designs manufactured, but also how our requirements being measured. We define GD&T with really tight flatness requirements, tight tolerances on parallelism, etc. But at the end, how are they measured? Are the measurements representative? Does the supplier use correct jigs? Do they use enough many points? Secondly, we need to challenge each other about the quality. As you see on the image on the right side, we want first time right designs with 0 repeats, 0 defect. At the end, we are looking for high yield. Hence, we have to be sure that from MPI to mass production, processes are under control. SPC is good. Lessons learned are implemented and documented. TPD is correct and up to date. All procedures are applied back to TPD. Lastly, and as equally important as the previous two, we need to care each other. There I would like to touch upon 2 major topics. Like we challenge each other for better quality, it is also how we care each other. A transparent open communication. Also care could be shown by detailed reporting. We must follow 8D template. It is not like this is the problem, it is your problem and solve it. But no, this is the problem, we have to first understand it with 5 W's. Does everyone know 8D problem solving? To be honest, we have to make sure all design teams and suppliers are trained for that. We need to have a clear problem definition, understand what is going on before we start with the containment or structural solution. Last 2 aspects of the left of the V model again worth emphasizing. Lessons learned. It has to be documented, shared with stakeholders. For ASML, we have technical competences for that. Lastly, a great mindset. I appreciate as an expat in the Netherlands, we really believe everyone does his job at his best. This, for me, summarizes Dutch way of working and culture at ASML. At the end, we are on the same side, on the same boat. 8D template. Before I end my speech, I would like to emphasize the importance of communication between the design teams and suppliers. For DfMA, securing manufacturing quality in design, a designer needs to know many things. I always say for becoming a good engineer, mechanical engineer actually, you need to have strong basis for DfMA. This is not easy as it is multidimensional. And most of these skills we need our suppliers to support us. Before I end my speech, I would like to emphasize the importance of communication between the design teams and suppliers. For ASML quality colleagues, it is revealed that timely supplier involvement has the most impact on value generation at an earlier phase. At the end, we are not only trying to reduce the costs, but also increasing the value. I would like to thank you all for your attention. Alone we can do so little, together we can do so much.